Hello, everyone. Welcome to my session. I'm Albert, the VP Engineering from Startup Cyber. It's my great pleasure to get invited to give a talk in the Graph+AI Summit organized by TechGraph. I think this is an awesome venue to share the idea regarding the Graph+AI topic. In my today's presentation, I'm going to talk about using graph machine learning to detect complex attacks in the open XDR context. XDR, the extended detection response, is a market segment defined by Gartner for security. It's a recently hot topic. In Gartner 2019, the top 9 security trend report, at least a #2 hot topic for security. In 2020, the same report lists as #1 hot topic in the top 9 hot topics in security. So in this talk, I'm going to give the high-level background and see why we need the OpenXDR and why the graph machine learning is a way we can, in this domain, to detect the complex attack and solve security issue better. The digital assets are targeted by attackers. That's well known, right? So in the traditional business, there's a lot of traditional business right now go through the digital transformation and digitalize all the information to present in the cyberspace. Also, the new internet-based business is already very much data-driven. So data, the digital asset, become a universal kind of tool we can capture what's going on in the real world. And then through AI and machine learning engines, then we can make important business decisions to enable the business. So a lot of business today leverage on data. And data also is a trust from customers to us as a business. Because customer gives the data, then they assume the vendor is going to protect data and maintain the privacy and also confidentiality for the data. Unfortunately, data is also very appealing for attackers. Attackers has been kind of long use different techniques to demonstrate their power for launching attack, but they also searching for a business model which can launch attack not only for fun but also for profit. So the data leakage and the ransomware has become an important way for the attackers to kind of monetize their attack and create their revenue, right? And also the cryptocurrency like Bitcoins and the other coins have given attacker an untraceable way to get money without get hunted. So because of this, actually, there's a great attention between business. We need to collect more data and use more data, but the attacker may kind of want to target for the data. It has been a lot of data breaches going on, right? This is one kind of figure is from the Information is Beautiful website. You can go to the website, get the same figure, all right? So it shows the world's largest data breaches. You can see there's tons of breaches happening today. And also, as I mentioned, ransomware has become another way attacker monetize through data. For example, Colonial Pipeline, right? It kind of stopped the gas shortage in the East Coast for a while, is caused by the ransomware, and the Colonial Pipeline indeed paid the attacker for the ransom. It shows the business model works. Given so much attack incentive, actually, according to the FireIM trend report, like attack deval time is still pretty long, and usually attack can on average 6 days, 2 months without notice or discovered by the company is they're under attack. This is contradict to actually the business might already have a SOC in place, the SOC Security Operations Center, and there's a lot of security analysts busy look at the screen and look at a lot of alert, but sometimes it's too many. They get alert fatigue. The wolf comes, but at the end they may miss the lion. So one example is like in a real customer environment, we found like one tool actually reported 90,000 alerts per day. Think about 90,000. If every alert in the 30 seconds take a look, it requires a team of 32 SOC analysts to work 24 hours a day. That is not realistic if people need to sleep. It needs 96 SOC analysts work in 3 shifts to cover that. That shows the problem is a real problem, right? The alert fatigue. And because alert fatigue, because it's so much like alert and it causes the security analyst incentive. When some real thing happen, it's harder to detect. For example, in the both well-known like data breaches like Target, it leaked 10 million credit cards, and Equifax leaked 1/3 of US citizens' social security number. In both cases, actually, if you carefully follow the news, the security team there actually knows something. But what they don't know is how important something they found, because after all, for a big company, every day there's security, some security attack happening. Every day there's something. But what they don't know is like in that day, the thing will cause huge data breaches, and even the CEO stepped down because of that. That is to show, right, for secure operation, it's not just a detection problem. Of course, we want to detection, we want to know and search all the suspicious behaviors, but that largely is not enough. We also need a rank function to know what's the ranking of top risk of the company. When we work with many customer, their CIO, the Chief Information Officer, and the CISO, the Chief Security Officer, is always asked whether you can show me what's the top 5 risk for my company for today. That become a critical business ask from the customer. Next, I'm going to show this is important, but also is challenging. Actually, if I show the search and the rank keyword, may make you think about the search engine. In the search engine, years before, they also have the similar problem, right? So before the Google, there are lots of search engine do like a search and it return the result, but the relevance sometimes low, the rank not good. And Google fundamentally through the page ranking algorithm improved the rank, right? So make the search much more useful. We believe security needed the same innovation. And also a hint is a page ranking is a graph-based algorithm. So that's why I think this is a good topic for this venue. So next I'm going to talk about why this is a harder problem. So suppose there's a DevOps laptop is compromised. You may find it runs some suspicious script or PowerShell. Then if you put yourself in a security analyst perspective, you must think about how serious attack is. Depending on how serious it is in the report, the escalation, right? Whether in the report to CISO or whether himself can handle that with simple response. Unfortunately, this question is pretty hard. So for example, one possibility is there's a large-scale attack, like a large-scale phishing campaign or some large-scale bottleneck or malware is going on. It happened to like infect this machine, but not targeted for this company. The attack also like infect many machines from a lot of companies. Then from that perspective, the SOC, the right decision is to clean up this laptop down, right? There's no further action probably need. On the other hand, there could be a different scenario. It could be still the same laptop get hacked, compromised, and also the laptop have exactly the same behavior. That's why we get similar alert. But this time it's different. The attacker is targeted attack to this company's critical data. Ooh, just like think about the Equifax, think about the Target. That it's something the CISO everyone should know. And actually, the attack might not start from here. Maybe start from through some phishing and compromise the secondary machine and use secondary machine to launch a network attack against this DevOps machine And from this type of machine, they get some important credential, then they move to the cloud side of the company and data center and launch more attack. And finally, they want to target the company's important critical database and customer data. Look at this figure a little more. Apparently, if this is happening, immediately this is a much more serious threat, right? But in order to figure it out, only have the information from this DevOps machine, it's not enough. You need a broader context. You need to know what's happening before and after, then changing the behavior to build the context to know what's really going on. And also, in order to build the context, in this example, you can also see it needs more than one security approach. It needs email security, it needs network security, it needs endpoint security, it needs cloud security. It needs probably multiple products data in order to stitching together to know this context. And this shows the difficulty of the problem. So number one, the context matter. We need to build a context. We need stitching things together to know what's going on. Second, in order to build context, we need fusion signals from multiple security segments. That's not easy today. That need open XDR. I'm going to show you in the next slide more. So why open XDR? Right. So let me to introduce what is the definition for detect response, XDR, and open XDR for you. So first, for any defense strategy, prevention usually is first line. It's just in your home, you need to install door and lock. That's prevention technology. And similar for a city, you might build a city wall, or like country, you also can build a wall in the border. That's always a prevention technology. But that is not enough, especially as big as city. For example, New York City. You need a detection response, which means you need a policeman, you need someone to investigate. Something is happening, then have detective, and then found what is happening and response to it. So that's going to be data-driven. So the detect response is an important security strategy we need to play. And then in the Gartner I mentioned, they defined a security segment in the market called extended detection response, XDR. Essentially, that is try to correlate multiple type of data. And initially, this term is coined by Palo Alto. Palo Alto is try to compete with EDR vendors. The EDR is the early vendors employed the detection response strategy. That's called EDR, endpoint detection response. And Palo Alto want to compete with EDR vendors and invent XDR to see EDR may not be enough. You need to also correlate with other data. But in their definition, the other data means same vendors data, means the Palo Alto's all other two can work together in harmony to offer the protection. It is good. But another side is also not enough. Fundamentally, in startup cyber, we want to push it to extreme. We want to call it everything detection response to redefine the XDR in a broader scope. That require all the data from all the vendors can be ingested. That's why we need an open ecosystem. We believe that's so important because for security, actually, is a fragmented market. We have so many vendors, then in order to state information together to discover the context I mentioned before, we need the open XDR. So that actually is related to this fragmentation problem in the security today. And that is kind of mentioned in another conference, in another talk. In the RSA conference, one of the largest security conference, 2019 keynote, the Pat Gelsinger, the ex-CEO from VMware, gave his keynote speech, 3 things the security industry didn't talk about, but should be. In that talk, he mentioned one data point. He mentioned when he was in meeting with CEO of Citibank, he asked how many security vendor you guys use. The answer is daunting. It's 250. What a complexity. In the same meeting, ask how many server vendor we use, it's probably 2. How many network area vendor use, including wireless, wire, those will probably 3 or 4. But security shows it's quite a fragmented market, 250. That shows we need an open ecosystem to get the data together to protect a company, because right now, no single vendor can offer the full protection for security yet. And also because customers already deploy so many tools, in order to return their investment, they need to consider how to kind of put all the vendors' data together. That's the open XDR. Then let's look at for Stellar Cyber's approach to deal with the open XDR challenge, right? So we call it a data or machine learning journey to instant. Because in security, we have fundamentally many types of data potentially contribute to the context building and know the importance of attack so I can better ranking so that I can focus on important things. First is network. When network data is important, you already have IDS, intrusion detection system, NTA, network traffic analytic, NDR, network detect response. All these tools can help us to know something endpoint cannot tell us, because after all, in any company, there's printers, IP phones, like IP cameras. There's lots of devices. Maybe it's IoT type that cannot be instrumented by agent. Endpoint might not have full coverage. Network data is still very important. Second, endpoint, right? Like an endpoint detection response or like an endpoint protection platform, like antivirus. They all give very important data to know what's going on in the company. It's machine. Third, the company may already have a lot of data integrations with SaaS, right? Like Office 365, G Suite, or like Salesforce, a lot of web apps, and also a lot of API integration inside the company. And also the company may already partially move to cloud. So might already use AWS, Azure, GCP, or Oracle, or other cloud. Then they might need to get the AWS Cloud Trio, CloudWatch, GuardDuty, or some type of data to know what's going on in their cloud from cloud vendors' view. That's important data as well. And then they also may have vulnerability scanner, like Tenable, Rapid7, to scan the vulnerabilities to know their security hygiene. They also may have identity-based tools such as Active Directory, Okta, or any single sign-on or like a zero trust tools to know the identity and the policy. So all the data is important, but they might speak in different languages. In Stellar Cyber way, we kind of first normalize the data and enrich the data to make the data more homogeneous so that we can let the data language become the same, so that can easily fit into the machine learning engine to make sense of it. And then the machine learning engine, the detection engine, may detect alert. The alert might further go through XDR kill chain. It's an industry standard like MITRE ATT&CK framework compliant tool to know the stage of the attack, to know the techniques and the process of the attack, so that we can legalize the attack to know the positions of the pieces. And then through the instant correlation machine learning, another machine learning tool, then we want to be able to recover what's really going on, who is really behind the scene, what's the big picture for the attack. Only if we know that, we can launch the response more intelligently, because if we know it's Joker, then probably we should throw the Batman into the battle. Similarly for any disease, right? It's best we do not only based on symptom to cure the symptom. Best we know the root cause and then have a systematic treatment. So from the detection machine learning perspective, the one fundamental thing is very important to make the machine learning really have good result is we need to make the machine learning model fit with data tightly, which means right model for right data. Fundamentally capture data intrinsic nature. Because the XDR, we have kind of different type of data, then we also need to use multiple type of model to do the detection. Like for example, here is a couple example, right? For the we use because in order to cover XDR all the different attack cases, we need to use a large set of machine learning algorithms from unsupervised learning to supervised learning to adaptive learning. In unsupervised learning, we need to use different models. For example, we needed to use time series analysis to understand something compared to own history, like for example, the power usage from my home compared to history. Then know, hey, one day it seems I use too much, then it's out there. Second, for example, we want to compare different employees in the company to know maybe the people can behavior as group by the group, then there are some outliers. Third is like from the graph perspective, not only we care about the data, and we also care about their relationship, like people's relationship, machines relationship, and so on. So then the abnormal relationship will be flagged. For supervised learning, we need to label and pre-train the model and use classifiers to detect things such as like we use it for DNS tunneling, the DJA domain detection through deep learning, and so on. And also because security analysts may have their preference, we need to gradually learn their preference, we need adaptive learning to achieve that. So I talk about the detection a little bit. Now I can't talk about the correlation, which need even more like a graph perspective in the machine learning. So fundamentally, the correlation machine learning, we need to build the context, as I mentioned. We believe the context is a cure for the alert fatigue. But how do we present context? Actually, context is easy to be presented as a graph. Here is the example, right? For example, the Alex going to send email, attach a report, and send to Exchange, and then land into the mailbox in his colleague. The Bob like opened this report through Excel, but unfortunately, this is a weaponized document, is attack. Then once it open, it also open a PowerShell and launch an attack. So this can be illustrated on the graph relationship. And on Charlie didn't open it, then not infected yet. So as you can see, right, for this context, we can encode it in a graph. And then once we can encode the context in a graph, then we want to leverage on the graph representative learning, the graph machine learning, to learn the context out of the graph so that we can know the attack context. That's the fundamental approach we have taken. So there's different graph machine learning techniques, right? More traditionally, we have the influence propagation, for example, TINA analysis. If we see the untrusted input, right? So then it might propagate through the program and finally to the SQL statement, then boom, launch SQL injection. That's one type of information flow propagation. And also page ranking fundamentally is propagated influence, but by the links between pages. And the deep work is a new like a deep learning algorithm, also leverage on random walk to sample the topological information and can train it into the deep learning model. That's one of the graph embedding techniques. So then graph embedding is kind of a good tool to use to help to get the topological information, encode it, and then convert to a vector space, because for machine learning guys, we all know the vector space is easy to use any machine learning algorithm to classification or find outlier or do anything we want. Then the third tool is the graph neural network, right? It's a new development, is try to see like the graph have topology information, but then topological information can be encoded into the neural network layers. So like A, then have the neighbor B, C, D. Then we construct the neural network assembly what's going on and train that way, right? So that is all good graph techniques, right? With those techniques, then fundamentally we want to be able to learn from the detection result to the incident, which represents the underlying of the attack, not just a symptom anymore. It represents the root cause from graph ML. And then the first thing it's going to do is help to group the alert together. And also once a group together, it also helps to rank the incident. with a group of activity so that we can give a score through the graph learning and then to know the rank so that we can know what's important. And also for each instance, then we can also have some detail to illustrate. So this is to show like in the product, we can rank the top instance, right? Then through the top instance, then we can know what is the top thread the company to worry about. Then we can drill down to one and to know the graph context as I mentioned, because the graph is a good language to describe the context. So then we can see, hey, then this machine may attack this machine like $1.25, and then it further attacks some other machine in the machine. There's some registry going on and install some key and so on. So we can get this context and also be able to also show that in a more human readable language. So with this tool, then people can quickly understand the context. So I majorly focus on two things, ranking and context. That really helped to solve the security challenge problem today. So then in conclusion, right, so as I mentioned, digital assets become important. But the attack are often, in order to solve the attack, we need to solve the alert fatigue problem. And the rank actually know the context, and the rank through context is so important for that. On one side, we need the open XDR to get have open ecosystem to get all the vendors' data to be able to stitch things together. The second, with graph machine learning, is a good way to encode and learn the context so that we can rank on the context well. And with both, then we can finally we want to achieve like a 10 to 100 boost for security operation efficiency against top risk, so that people can, as CISO or CIO, they can quickly know what is the top risk for my company and have peace of mind that those cases get handled. That's my talk. Thank you.